Hello, right, this one. This is a lesson on rounding and estimating. I suppose I could have typed that in, estimating, beforehand. Save time. Anyway, it doesn't matter. Rounding and estimating. Two different things. Now, they are linked together. Imagine you're going around the supermarket and you're putting things in your trolley, $4.99 and $3.75 and $2.15, and you want to get an idea of how much things are going to cost. You would estimate. You'd say instead of $4.99, you would round the number up to a fiver, and then you think, oh, £5, £2, £3, and you'd get an estimated expected bill when you got to the checkout. Now, rounding in itself has a few rules to go by, and rounding is something that we do at the end of a calculation, and estimating is something we do at the beginning of a calculation. So you can round to the nearest, say 100, yeah? And so if we had 96, 241, 318, 778, and you'd round those to the nearest 100, and you'd think, well, 96, you'd think, well, I've got 90 at that, or to the nearest 100, so it's not rounded to the 10. So I'd have nothing at that end, and I'd have 100 there, and then my 96 would be in there, so it's quite close to the 100. So that would be rounded up to 100. And the same with this, 241 is nearer to 200 than it is 300. It's about there, 241. Oh, there. So that would be rounded down to 200. 318 would be rounded down to 300. And 778 would be rounded up to 800. And we can round to the nearest 100, and we can round to the nearest 10, and we can say, okay, 14, 38, 52, that would be rounded down to 10, rounded up to 40, and rounded down to 50. Yeah? Now, what happens? There's a rule here. There's a rule to remember. What happens when it's in the middle? Say if I take the number 55, and it would be, there was 50, there was 60, and the number 55 is right in the middle. So it's not nearer to 60 and it's not nearer to 50. So this is where the rule comes into. When it's 5, go up or round up. Round up. When it's 4 or less, then you just ignore it. You go down. So 35 would be rounded up to 40. 65 would be rounded up to 70. So you're going up and down. You can also round to decimal places. Right, so 3.18. Now, let's take this one, and I'm going to round to 1 decimal place, just in case you see that as an abbreviation. 1 decimal place. Now this means that we want this number to be rounded so we see nothing after the first decimal place. So there is our first decimal place, which is immediately after the decimal point. Now the number that determines whether you're going to round up or down is going to be the next number along, the 8. So if it's 5 or more, you round up. If it's 4 or less, you ignore. Yeah. So the 8 is definitely more than 5, so we round up. So that means you add 1 on, to the number 1 there. So your answer becomes 3.2. It's like rounding 18 up to 20. There's a 2, but there's no need to put the 0 in the end, yeah? So that's to 1 decimal place. So let's do that again with a different number, 3.12, yeah? So we're going to round this again to 1 decimal place. So there is our first decimal place, and this is the decider number. Now it's less than 4, or it's 4 or less, so we ignore it, we just lose it. So our answer is there, 3.1 to 1 decimal place. We could round to 2 decimal places, and you won't go any farther than that in functional skills. You'll get quite an involved calculation where you're working this, that and the other out, and after about half a page of working out, it says, oh, don't forget, round your number to 1 decimal place. Yeah, and you'll get an extra point for that if you remember to do that. So let's do 4, 2, 6, 8, 7. Yeah, lots of numbers here. Now to 2 decimal places. There is our second decimal place. To the right of it is the decider number. This is 5 or more, so we round up and add 1 back onto the 6. So that becomes 4.27. The rest of the numbers doesn't matter. This could be 99999. Just doesn't matter what there is there. Now, let's do 3.63142 to 2 decimal places. So there's our second decimal place. Here is our decider. It's 4 or less, so we ignore it. So 3.63 to 2 decimal places, and always put this in the bot there, so we know what we're doing. Yeah? Now the only complicated bit you might get is, say if I want to round to 2 decimal places, and we get a number like 3.9999. Yeah. What we can do, 2 decimal places, is this one, and there is the decider. It's 5 or more, so we add 1 onto the 9, but that becomes 10. So we have to add 1 onto there, which becomes 10, and then it becomes 4, because we've gone like, it's like 399 plus 1, isn't it? So we get there 10, 9 9 is 10, and it is 4, yeah? So it's 4.00. Now it's very, very unlikely that you'll get anything like this, but in this case, 4.00, I recommend, although ordinarily we would never put the zeros in, I recommend that in this one super blue moon rare occurrence, if it ever happens, that you put the zeros in there to show the examiner, the marker, that you have actually done that to 2 decimal places. Okay, let's have a look at some. Oh no, I haven't done estimate, have I? Let's do an estimate, yeah. Getting ahead of myself now. Estimate. Now, estimate is something you do the beginning. Yeah, we've done the rounding. Estimate is something to do with the beginning. So say we've got £4.99 plus £3.05. This is all money, or it could be decimals, doesn't matter. Plus 14 pound and 8 pence, plus £1.99. And we want to estimate what the total is. Now, do not go to even if you've got a calculator, don't go to the trouble of adding them all up together and then rounding at the end. No, you estimate first. So you'd say that's about a fiver, that's 3, that's 14, and that's 2. So you've got 8, 22, 24. So an estimated answer of 24. You use your discretion of whether you're rounding up or rounding down. If you have 103 divided by 19 and you want to estimate the answer to this, you call it 100 and call that one 20, and 100 divided by 20 is 5. Yeah, and you'll find that in questions they give you, you see how we've rounded this one down to 100 and we've rounded this one up. So they sort of, they counterbalance, they cancel each other out, where one number's gone up, the other one's gone down. So that's just estimate, where you pick a sensible number so that you can almost do it in your head. Righty right. Let's have a look at some of these. Round these numbers to the given number of decimal places. So we've got 2 decimal places, 1 decimal place. Then we've got rounding to the whole numbers, and then some more involved questions. So have a go at these, pause it, and then come back and see how we did. So 1024 to 2 decimal places. Well, there's the second decimal place, the 2. There's the decider, which is the 4. This is less than 5, so we can ignore it and just put 1.02. This one to 1 decimal place. There's the 1 decimal place. There's the decider, it's 7. It's 5 or more, so we add 1 back on to get 3.6. Now we're rounding these to the nearest whole number. So really what we're taking notice of is this first decimal place, because there's the whole number, the 1. And so we're looking at this one. So that's the decider. And 8 will we round up to call that 52. And this one, the decider is the 4, so we just ignore it and call it 5. A racetrack is made of 3 sections. Daniel does a lap, which takes 18.638 seconds in section 1, blah, blah, all these seconds in 2, and all these seconds in 3. Estimate how long Daniel's lap took. Estimate, okay. So lap 1, I'm going to call that 19 seconds. Lap 2, I'm going to call that 33 seconds. And lap 3, we'll call that 19 seconds as well. So if we add these 3 up, we will get an answer as 38, 68, 70, what? 71 seconds. Now, I'm pretty, sex. S-E-C-S. Right. Now, I'm pretty sure that you might be able to get away with this. Now, all depends who writes the questions and what they're expecting. I know that sometimes when you do exercises online, the computer is looking for a specific answer, and if you do it a different way, it will say no, that's not right, and there's no argument with it, it's just got to be. But you could do, that's about 20 seconds, that one's about 30 seconds, and that one's about 20 seconds. Yeah? So you could even round it down to whole numbers, or to the nearest 10 really, which would give you 40, 50, 60, 70, give you 70 seconds. There's only one difference. Dyslexic. seconds. Right. Only one difference. So either of those is fine by me. It's potluck of what way the examiner, what way the question maker wants you to answer it. But yeah, it's just estimating. So do all the rounding bits before you calculate. So the formula for the area of a circle, oh, this is a later lesson, yeah, is A equals pi r squared. Don't need to worry about pi r squared, or do we? Yeah? Where A is the area, r is the radius of the circle. There's a circle, the radius is just from the middle to the edge. And estimate the area, less always comes in the question, where pi is 3.142 and r is 8.6. Okay, so the area equals pi r squared. So it's my little trick. Always write that down. Gives you a couple of seconds to think about what to do. So pi we call 3 times, because this is algebra when you've got letters together. That's a Greek letter, by the way. You multiply. So r squared. R is 8. Do you call that 9? Yeah. 9 squared. We'll get on to squares and all the rest of it later. 9 squared just means 9 times 9, 9 times itself. That's 81. So then we've got 3 times 81, which is 3 ones are 3 and 3 eights are 24. So 243 centimeters squared. Okay? Right, so that's the end of rounding and estimating. And there'll be a worksheet to go with this one. And I'll see you in the next one when we're on to percentages.